Alright gang, so here we go with Graphing Polynomials Part 1. This is actually section 2.3 in the book. And we're going to talk about polynomials, give a definition, and then we're going to start graphing them. So we need to know what our end behavior is. The leading coefficient is actually going to tell us what that end behavior is. We'll look at zeros of a polynomial and then multiplicity, which actually also has to do with the zeros. So to start off with, a polynomial is just going to be a sum of terms where the degrees of each term are non-negative integers. So integers meaning we don't have any fractional exponents either. So essentially everything we've been working with this year except for no rational functions and no radicals. Okay, leading coefficient just means the coefficient of the term with the highest degree. So if our highest degree is 4 or is the fourth, that means our highest exponent is 4. Okay, so our degree is our highest exponent in the polynomial. And then if we say something is smooth and continuous, it just means that there's no sharp corners and never breaks, or you could also think of breaks as gaps. So end behavior means what does the graph do when we are at opposite ends, so far left and far right. When we talk about polynomials, meaning far right, everything's either going to be going off up to positive infinity, or the function is going to be going down to negative infinity. And at the far left, same idea. We're either going to be going down to negative infinity or up to positive infinity. Okay, so that's how our graph behaves. Now, every polynomial is going to have this kind of behavior. It's going to be going either up to infinity or down to negative infinity over here, and likewise either up to positive infinity or down to negative infinity far left. Okay, so the leading coefficient test is going to tell us what that end behavior is. And that means if n is odd, and when we say n, we are talking about the degree of the function. So if n is odd and a, which is going to be our leading coefficient, is positive, then as x approaches infinity, f of x also approaches infinity, I should say, not negative infinity. Approaches infinity. Okay, so that would be far right, meaning we're going up. And the opposite then, as x goes far left, meaning negative infinity, f of x is going to be going down. Okay, when we change the sign of our leading coefficient, meaning we make it negative, then the opposite thing is going to happen. As x goes far right, f of x is going to be going down, which means negative infinity. Likewise, as x goes far left, our f of x is going to be going up then. Okay, so this is when our degree is odd. That's the big piece here. Second part then is if we say our degree is even, as our leading coefficient is positive, then as x goes to positive infinity, as x goes to positive infinity, f of x is also going to go to positive infinity. And because it's even, as x goes to negative infinity, f of x is still going to go to positive infinity. Okay, when we change that thing, everything switches. So as x goes to infinity, f of x now is going to be going to negative infinity. And likewise, as x goes to negative infinity, f of x is still going to negative infinity. Negative infinity. There we go. Okay, so that's our leading coefficient test. So if we look at something here, you see our leading coefficient is 11 and our degree is 3, which is odd, and this is positive. So that means that as x goes to positive infinity, this function, the values, f of x, are also going to go to positive infinity. And as x goes to negative infinity, the function f of x is going to go to negative infinity. Which means if we had our graph, if I had a grid on here and a y and an x axis, that as we got really big for x, we'd be getting really big for y. Whoops. And as we got, let's see here, as we got really far left for x, we'd be heading down for x. Okay, so that's going to be our end behavior, what happens at the far left and the far right. Next thing is going to be zeros of the polynomial. That just means values, just means values for x that will make our function 0, meaning f of x is 0. They're also called, and we've talked about this, roots, solutions, or most recently our x-intercepts. And then we can talk about multiplicity of a 0. So multiplicity means the number of times that a value is a 0 of a polynomial. Okay, and so what that means, if we go to jump to a couple examples here. If we looked at this polynomial, we know that x equals -5 is a 0, and we also know that x equals -2 is a 0. This exponent actually tells us that -2 is a 0 twice. So we would say with multiplicity 2. And the second one, x equals 3 is a 0 once, because there's an exponent of 1, just like up here. And x equals -6. Again, there's an exponent of 3, so that has multiplicity of 3. Now that doesn't mean that 3 is a 0 or this 2 is a 0. It means that is a 0 3 times. And what that is actually going to tell us about the graph is that the polynomial will touch the x-axis when our multiplicity is even. And it's going to cross the x-axis when our multiplicity is odd. Another thing about multiplicity that helps us out identify how the graph is going to look is that as it increases, the graph is going to flatten out around our x-intercept, which also, remember, is a 0. So if this has a multiplicity of 2, we know that this is only going to touch, not cross, the x-axis. And since the -6 in our second example has a multiplicity of 3, this is also going to cross. Okay, since the 3 here has a multiplicity of 1, that's also going to cross. And since the -5 has a multiplicity of 1, that's also going to cross. Okay, so that's going to tell us some behaviors about our graphs. We will then finish up our second part, and then we'll be starting to throw some graphs together of our polynomials. Okay, so we went over end behavior, which what happens really far right, really far left. Our leading coefficient test tells us that. And then we talked about zeros of polynomial and their multiplicities. Remember, zeros could also be referred to as roots, solutions, or most commonly that we probably use the x-intercepts. See you next time.